What's going on, guys? We're going to do a video really quick on stretch because it looks like the next task 2.2, the one that you're about to do, it expects you to know how to do stretch and how to deal with stretch, how to get the equation, but you never learn anything about it. So I'm going to show you how to look at stretch from a table. And so you'll just know what to do. So you'll notice in the black that you have the table of the parent function. I didn't put the x value of 4, but it doesn't really matter. And you'll notice that from the vertex, that means you go over 1. I'll use my mouse here. So you go over 1, and then you go up 1, over 2, up 4, over 3, up 9. Now, what would be the difference if I had a stretch of 2? Well, your x values always stay the same. So we're going to put your y values now in red. If you're stretching, your vertex stays in the exact same spot, but all of your movements get multiplied by whatever your stretch is. So we're going to say times 2, times 2, times 2, times 2, because my stretch is 2. Right? If your stretch is 2, then you multiply everything to get the new y values. So 0 times 2 is 0, 1 times 2 is 2, 4 times 2 is 8, and 9 times 2 is 18. So these are the new y values, and these are the same x values, right? Now, we could do the exact same thing if the stretch was 1/2. All right, so all we're going to have to do is multiply everything by 1/2, or multiplying the original equation by 1/2. Okay, so 0 times 1/2 is 0. 1 times 1/2, remember multiplying by 1/2 is the same as dividing by 2. So 1 divided by 2 is 1/2. 4 divided by 2 or times 1/2 is 2. And this one's going to be 9/2 or 4.5. But all of my values got multiplied by 1/2 because my stretch was 1/2, and over here, all my values got multiplied by 2. The values you're multiplying are your original values. So obviously you wouldn't have all these tables together. They would be separate. So let me show you what that's going to look like. So here's the Desmos. This is a graph of your parent function, just so you can see. And you can see the table over here on the left, all my normal functions. If you wrote the other table down, which you better have, then you'll notice it is this table. Okay, and all my values have been multiplied by 2. So instead of going over 1, up 1, you go over 1, up 2. So over 1, up 2. That gives me my next function. Over 2, instead of going up 4, you go double that, which is 8, and so forth. So there's stretch explained. And here's the 1/2. The 1/2 ones are trickier to see by a graph. So if you're given a graph like this, and you say, okay, what's my stretch? Over 1, up 1. No, it didn't go up 1. Over 2, up 2. And you go, 2. How is that related to the normal 4? Oh, that's half of that. And so you realize the stretch is 1/2. All right, this is what the problems are going to look like. Number 1 is a little bit tricky. I'll go over that in a second. Number 2, you just need to find the equation. Remember, it says write the equation for each problem and use a second representation. So if it already gives you a graph, you can give me a table. If it gives you a table, give me a graph. So you're just going to go through that. And then once you get to 5, 6, and 7, it's going to have you graph those equations based on the information you knew from vertex form from a couple days ago. And you're going to graph them on some graph paper. And then lastly, you're going to answer just some basic questions about vertex form. And instead of the word dilation here, you can go ahead and put stretch. So go ahead and change this word right here to stretch. All right, back to problem number 1. Remember that you've seen stuff like this before, but this was before I went on my little break. So you always start off with a square that has a side length of x. So it tells you start off with the side length of x, then do something to the side length. Once it tells you to change it to area, then you say, okay, what's my side length? So let's just do a random example. Let's say the problem says side length of x that's been increased by 3. Okay, so that means we're going to add 3, but it's a square, so that means all sides look like that. And then it starts talking about the area. Well, now we know the area of this square is this. And so then start changing the area and see if you can't get the equation. Okay, so that's that. All right, and then the next time I see you, we'll go over the answers for these. And if you guys have any questions, you can go ahead and ask. But I don't want to give you too many of the answers right now because I want you guys to fiddle with this. And if you have to check your answers using Desmos, go ahead and do that. You shouldn't need me. If it says graph it without using technology, that means graph it on paper using all the skills you know. And then I definitely recommend checking it with technology. All right, have fun, guys.